So first thing that I'd like to take a look at this is our course outline and see where we stand on the progress of our topics to cover. So we're still somewhere in the process of covering our initial presentation on Java Swing Forms. And so I'm just definitely going to open it again, and actually I'm going to open the presentation format for it. Okay, and so we had just a quick refresher of what we have already covered, right? So we had this discussion about the fact that when you use graphical user interface, what needs to happen is that any work that you do with Swing components, which is the Java library that we use to code and to represent our windows and controls on these windows, everything that happens to Swing components needs to be organized, and the work has to be done on the background thread called event dispatch thread. And that event dispatch thread is reachable by other threads, such as this main thread that we get when the application starts, right? So this main method is invoked on the main thread, and so what it does, it essentially delegates a call to this method in our main class named create and show GUI, and it's this this main method guarantees that the need to make that call is inserted into a queue for event dispatch thread responsible for delivering these the elements of that queue to the event dispatch thread, and it happens. And so this gets invoked, and we, as you can see right here, we construct some kind of a J-frame, and then we start populating it with gadgets, and so forth and so forth. So we've demonstrated a number of techniques using code written by hand, which is pretty much the core part of this entire presentation. But also we, on Thursday, we had a chance to discuss the possibility of using NetBeans Designer to put together our forms. But by comparison, I think that you should see that what NetBeans Designer does is just essentially generates code to create windows, and windows with controls and gadgets and widgets, all of the variety that is available to us, right? So today, I think I think we have enough knowledge already so that we can give a priority to our next homework project, which is assignment 5 right here. I'm going to actually go ahead and open it in our homepage, right? So this is assignment 5, and it's called New Year's Resolutions. So assignment 5, just a standard handout, as we we've done many times. We just have the description of the problem to solve and some requirements and advice in order to how to approach this. Okay, so with this homework, I would expect you to actually use NetBeans Designer because it's much easier and it's much more straightforward, and it's easier to maintain the code. So if we do create a prototype for this specific homework today in class, obviously I will be using NetBeans to display the views of our application. All right, so very soon we're going to switch over and talk about this specific homework assignment. But for now, I'd like to continue on with this with a few more slides. So we already discussed that the nature of Swing components, and then this is something that I said we're going to cover in just a short while, because this is an interesting aspect of developing applications with a sophisticated user interface, right? So typically you have a user who is sitting in front of the desktop of some kind, if this is a business environment, not necessarily your tablet device, but maybe it's a desktop computer, or maybe it's a laptop. And so they have a desktop in those environments, and maybe they want to run an application which is installed on that desktop, which would be the case with our samples, or maybe it's an application which is running inside the browser and just uses a network connection to delegate all the work to the server side. Regardless which case this is, I think that we need to be able to recognize early on that we have three major layers or tiers of such application. One part of it is the view. The view is what's visible to the user. The view is what the user is interacting with, right? So the formal definition of view is that if you have a specific use case, for instance, maybe you have a use case that the user is trying to execute, and they have to enter a form with data and click the save button, right? So all of this collection of the data, clicking the save button, basically needs to talk to the rest of the system so that the data is properly updated. Now, if we have this type of application, maybe we should also give recognition to the model part of our application. The model stands for the data model, right? So if we said user view, so then the model stands for the data model. In fact, if this is an application that does something for business, like maybe a spreadsheet-like interface, then the user can enter data, but some data objects with formulas built into them could run certain processing and complete certain updates and do things alike. All right, so the data model simply is a set of objects, described of course by Java classes, which are specifically designed to retain the information produced by user interface, right? So we're trying to make a clear distinction between the user view of the system and the data model, which internal representation could use array lists, different types of collections, data objects placed in those array lists, and I mean the possibilities are endless. So internal representation of data may not be necessarily something that we would like to expose to the user, or with any time we need to modify a class that represents the user view of the system, we probably want to make changes to the view and not to our data model, and vice versa. If we have the changes in the data model, the changes in the data model not necessarily are affecting the view, right? The view may be the same, but we change some formulas. So ideally, by design, we should pay attention to this type of setup so that we recognize certain layers or tiers inside of our application. And so the model view controller design is a good advice in terms of how to write applications with sophisticated user interface and substantial complexity of the data model. So the interesting part of this is, what's the controller, right? So what does the controller do? Well, the controller class is basically the class that is responsible for managing both updates in the view initiated by the rest of the system, as well as providing methods to the view, to the graphical user interface or console style user interface, to provide methods to update the data model. It sounds like the role of the controller happens to be, it looks like, controller, maybe it's a redundant piece. And so what's the importance of the controller?